The broadcast is now starting. All attendees are in listen-only mode.
Hi there, it's Lisa Travers from Alliance Corporation. Thanks for joining us today. I have Carrie Downer on the line. Carrie is going to be the presenter today. I'm the Director of Marketing here at Alliance, and I hope that you enjoy this webinar today. I hope it answers any questions you may have about fiber to the antenna. And any questions that you don't have answered, please don't hesitate to email myself or Carrie with anything at all. So to tell you a little bit about Carrie, if you haven't read about him already in his bio, Carrie comes to us with 25 years experience in the industry, in the telecommunications industry. He most recently was with CommScope, working with fiber to the antenna. So he has a great deal of experience in the, specifically with fiber to the antenna. And Alliance has been working with fiber to the antenna since early 2010. We're glad to be able to transmit some of this experience to you. So over to you, Carrie.
Okay, thank you, Lisa. Hello, everybody. Thanks for joining us on this wonderful week. Friday afternoon. It's beautiful here in Connecticut, and I know I've already heard around the Toronto area it's also gorgeous. So thanks for taking the time to go through this presentation. As Lisa said, any questions that you have after this, please do not hesitate to forward them. I do have a list of questions that were sent prior, and I'm going to try to answer all those to the best of my ability. We're going to go through this speaking more of the experiences that I've had in the past work at both CommScope and Cable Design Technologies, and then also what we're currently doing at Alliance. So I hope you don't think it's too self-serving as far as an advertisement for Alliance. However, with this being such a new area, it is important to understand that a lot of the developments in this industry are happening day to day as far as choices of deployment and strategies and the solution set. So speaking to what we're doing is probably the best way that I think we can communicate what's happening right now in the industry. So the first slide reads fiber to the antenna solutions for remote radio head deployments. Now we focused on obviously LTE and 4G as a driver of this solution set, but I've spent a considerable amount of time in South America and Latin America where remote radio head deployments are using fiber to the antenna solutions for 2G, 2.5G, and 3G solutions as well. So it certainly is not relegated just to 4G. In fact, much of the ballyhooed deployments that are happening in the U.S. right now, although they tell Wall Street they're doing it on behalf of 4G, they're actually utilizing this solution set and architecture for all other technologies moving forward. And the 4G deployments will be a portion of that initially and part of the development of their network going forward. So it is a very versatile solution using the same components that we're going to be discussing here. And I just want to, 1 second, move to the next slide. There we go. As Lisa mentioned, I have 25 years experience in the industry. I did focus the last 6 years on fiber to the antenna solutions on behalf of CommScope Andrew. I've been working with and for Alliance for the last year, but I've actually been working with them for over 5 years on the development of different solutions as well as one of my customers prior to my joining Alliance. I just want to go through the general agenda. We're going to go through the Alliance overview, fiber and DC cable solutions for the fiber to the antenna solutions, remote radio head deployments. That takes 3 different flavors, really, as far as the architecture: composite, sectorized, meaning separate discrete runs to radio heads driving sectors of a site; composite trunked, which usually requires some sort of junction box or squid and then is broken out to the various sectors; and then separate fiber and DC, which take both a trunked form and a sectorized form. So we'll go into our trunk cable manufacturing here at Alliance, which is something that we've quickly become an industry leader in. Jumper manufacturing, which is a key aspect of these product types, especially for the composite trunk solutions. Logistics, which is really one of the key drivers in successful deployment, in that all your tower-based accessories, hardware, and everything have to logistically be there for site deployments. And the fixed length aspect of these jumpers is a key driver to the success, and understanding what your sites look like, and then accessories as well. Just want to go through a bit of the background of Alliance. Alliance is a wireless innovation and logistics leader helping carriers build next generation 4G LTE networks. That's become our focus over the last 3 to 4 years, as Lisa noted, and we continue to drive towards that direction right now. And here's a general overview. Founded in 1993 with a headquarters in Mississauga, Canada, 300 people throughout North America. Site solutions, cable assemblies, towers, accessories, broadband radios for the wireless industry. 100+ leading manufacturer partners and our own solution sets. And an innovative market leader with several firsts in this fiber to the antenna area. We support cell sites and cell builds throughout North America. We have multiple facilities, which we'll go into in the next couple slides. And we work with the top tier carriers, AT&T, T-Mobile, Sprint, Verizon, Bell, Rogers, and TELUS, Royers. And one of the innovations is, when I was with CommScope, easily Alliance became the leader in deployments for remote radio head deployment using a hybrid or composite fiber and power under one construction. And they did receive an innovation award from CommScope on those deployments on behalf of a Canadian operator. Looking at the locations, as we talked about, the Mississauga facility is our headquarters. We have facilities in Canada, in Montreal, in Canada, in Calgary. And then we have a Syracuse facility, which is a distribution facility in the U.S. We have a New Jersey distribution facility, a sales office in Chicago, a distribution facility in North Carolina, as well as a fully integrated distribution facility in Denver, supporting a lot of this fiber to the antenna throughout the U.S., and facilities in Juarez and Mexico City. The Juarez facility and the Mississauga facility are our primary manufacturing facilities for fiber to the antenna assemblies. And we'll get into a little bit of that being one of the key areas. And from the questions we received about the quality of products and the testing prior to deployment and after deployment, that's one of the key areas for the group who has kindly joined us today. So just going into what key areas of Alliance is involved in, we have a broadband division. We have an in-building division. We support supply chain initiatives throughout all of these parts of the business. And then wireless infrastructure, which fiber is one of the key and strategic directions for the company going forward, are all supported. And as we talked about, the supply chain and logistics aspect of that is really key. Here's some of our partners. If you're looking just for fiber, there's Corning, Draka, and CommScope here as key suppliers to us in that area, and Prismian. And then we have Raycap as well, who has taken a leadership role in the squids or junction boxes or COVPs that are utilized for these fiber deployments. And that's a key area where we have our own brand of those as well. And then here are some of the customers. Many of the people registered, and I'm sure who are on this call, who I recognize names, are from these companies, like TELUS and Bell and Royers and others. So we've worked on, for many of the companies that are listed here, specific architectures and solutions to drive their remote radio head deployment initiatives. Fiber deployment history. As Lisa indicated, we've been working in this area since 2010, which was, I'd say, much quicker than the U.S. deployments had gotten started. It interestingly enough, Latin America and Canada have seemingly been the early adopters for remote radio head technologies for a variety of reasons. Over 5,000 sites have been deployed by Alliance throughout Canada, and we've worked with several of the carriers on fiber to the antenna projects throughout North America. We've developed solutions in conjunction with Draka Prysmian, Corning, CommScope, and other cable manufacturers for key customer deployments. And we'll get into some of the specifics of why that's important, that we're an agnostic there and we're not held to one supplier, because it is key to be able to meet the needs across the board. And from OEM to each operator, we've seen dramatic differences in deployment strategies, expectations, criteria, and specifications. So the solution set. We have full BOMs for known solutions. So that's OEM and operator driven, as well as custom solutions. If we look at the OEM aspects, I think most people probably know most of the key OEMs, Ericsson, NSN, Huawei, Alcatel-Lucent, Motorola, Samsung, ZTE. And I've worked over the last almost 6 years with each of those OEMs on some level, some more than others, in developing the solution sets. Articulated Alliance end-to-end fiber solutions under our fiber LTE brand include terminated assemblies, transmission cables and jumpers, enclosures, as we mentioned, COVPs, fiber management, and excess cable storage. Those are all key to the deployment strategy. Cable connectivity, assemblies, and integration expertise as to look at the various connectors and cable configurations, the system design capabilities, and what customer-specific requests that requires, as we talked about. OEM and operator-driven product sets, and those can vary widely. Right now, I'd say we're the leading supplier of solutions within North America currently with the volume that we're doing. We do have published procedures for grounding and breakout, extension techniques, which is really key in handling of the products on the site itself. And then one of the keys from our past legacy of being a wireless distributor, obviously knowledge of all tower-based and installation hardware, RF components, and accessories. So that's hangers, hoisting, grips, grounding, standoffs, mounting hardware, and then the fiber-specific handling, protection, and testing, which I'd say about half the questions that came in prior to this discussion entail. So just want to go into, and the first part's a bit redundant, but want to establish the fact that we're supplying solutions as Alliance Communication Cables in the U.S. and Alliance Corporation in Canada, and that includes the cable, the site-ready assemblies, jumpers, excess cable storage, OVP, fiber management boxes, along with all the accessories. We use multiple suppliers for the cable connectivity. So CommScope Andrew was one of our first partners. We've worked with Draka Prysmian, Corning, Belden, Chinese suppliers if needed, and with connectors, we've utilized Senko, who I believe is on the call, one or two people, Amphenol, Tyco, Radial, Huber & Suner, Corning, CommScope, and Prysmian. We do currently use Senko for a lot of our manufacturing of assemblies. And then one thing to go over is the real key to this is everything in this deployment is driven by obviously a quality fiber assembly, but one of the key areas is the DC component and the gauge size of the DC component. So what you have is effectively a voltage drop allowance for each OEM radio. And so that dictates the size of the DC component that you need to power the radio with enough headroom that you're not running into issues. And that boils down to the DC resistance of the copper that you're utilizing for the power component. And so a lot is driven, in the old wireless world, we always looked at a coaxial cable and its attenuation or insertion loss as the real issue, driving which size coax that we needed to run a particular system on a tower or at a BTS site. And now we really have to look at it and determine what size power conductor is required for the specific radio that's being put at the top of the tower. Now, I know not 100% of these deployments are going on the tower top currently. In fact, one of the leading carriers in the U.S., Verizon, it has not made that their deployment strategy as of yet. They're just experimenting with it. They're still utilizing the bottom of the tower for these remote radio head entities in the radios. But most other operators are working a strategy where the remote radio head is mounted at the top of the tower. So the DC conductor is really a critical value. Now, for those who need it, I do have a conversion chart that gets into the DC resistance and effective run lengths for each of the conductor sizes, and I can forward that at another time and send that. But with an hour for this presentation, I didn't think we'd have time to get into all those details. But that is a very important aspect, whether you're using composite hybrid sectorized, hybrid trunked, or separate fiber and DC sectorized or trunked. You still need to determine the size of the DC conductor that will drive the radio that you're utilizing. So that's a real key item. So the solution components, capturing and defining the BOM. This is critical for the success of the program. One thing we looked at, you can have a great cable, but if you didn't have the proper tower accessories to hang it effectively and efficiently and safely, the deployment will not happen. So the solution components that are important are the cable, assembled feeder and jumper assemblies, breakouts, weatherproofing and terminations, fiber management and distribution for any trunked and sometimes sectorized, DC management and distribution. Sometimes they're separate. Sometimes they're included in the overvoltage protection or COVP. Excess fiber storage and cable storage, as you are probably understand that most of these assemblies are pre-assembled. The very little assembly or fiber assembly is being done on site for a variety of reasons, both the integrity of the fiber performance, logistics, and also deployment time frame and expense. Somebody doing fiber splicing is a lot more expensive than somebody just pulling cable on a site. And then shelter-based frames, racks, and panels, we'll get into that a little bit more. And then testing equipment and training, which is a whole separate webinar that we'll have to get into. We will talk to some of those topics, but we will not have time for all of them. So I just give you a typical BOM here, and looking at 19 different areas of components that you need to consider in a remote radio head deployment or a fiber to the antenna deployment. So there's a lot to consider when looking at this strategy and what you need to bring to the site. Just want to get into the experience and logistics. Obviously, we just talked to it, 20 years of experience. We have now supplied, while we talked about 5,000 sites deployed throughout North America, we have 10,000 sites that have been supplied. And right now, that constitutes 25,000 plus of assembled links of cable. So that's a considerable amount of experience when you look at the whole body of work, considering that operators had deployed very few of these sites until last year when AT&T got going. And certainly Canada was well ahead of that with Rogers and TELUS and Bell. Here's our facilities and locations. Mississauga, fiber manufacturing, as we talked about. Then we have Syracuse, Lincoln Park, Denver, and North Carolina, as well as distribution facilities. We do fiber manufacturing in Mexico near Juarez. And then we have flexibility where necessary to bring and perform these same entities and bring the model that we have in Mississauga or Mexico to any other location if needed for any particular piece of business. But right now we have plenty of capacity to support any initiatives we've seen in North America. And here we'll get more into the 4G solution. I'm going to oversimplify this, but this is why operators are choosing this, and many of you are probably working for an operator and know this. For 4G technologies, they needed to find the lowest loss. Coaxial cable standard loss of a coax was not going to be withstood for the deployment of these radios. So they had to look at fiber optic products for a long time for this deployment. But they have been looking at this for a long time. Obviously, in the wireline world, fiber is the standard for the deployments of long-haul fiber are key to the networks. One of the things you should understand is that I actually developed these type of products, remote radio head products, over 10 years ago. But it's just in the adoption of tower top electronics, it took so long to come about, until the last 3-4 years that we've had to go in and redesign the product set, obviously utilizing newest technologies, which all of our solutions reflect. So looking at this, as far as a composite hybrid cable being deployed, it's the lowest installed cost, pricing and installation, lowest leasehold cost, which is really key in the U.S. As most of the towers are co-located. So that's the fewest components and the minimal number of cable runs. So the least amount of rent that you can pay per month. Obviously, OEM directives towards RRH remote radio heads has taken off. I mean, it's a trend that's been started in other regions. So obviously, they want to gain their highest efficiencies and manufacture those products rather than going back to standard BTS base transmission stations for other deployments. Protection of the fiber. If we use a composite cable, we can eliminate conduit. And safety. For the power, you can eliminate conduit and still have an outer conductor that you can ground. And then you have the safety of the power conductors being sheathed. So here's choosing solutions and remote radio head considerations. So one of the keys to this is understanding who the OEM is. If you have the information on the remote radio head and the specific OEM and model number, we can come up with a solution that'll work for you. I mean, there are variations on what a Huawei radio requires as far as power, meaning those DC components that we discussed earlier, and what a NSN radio might need. You need to understand fiber count and type. How many remote radio heads to feed? Are they going to be? Are you going to run an individual or sectorized approach, or are you going to run a trunked approach? Can you withstand having a junction box on the tower to break out to the various radio heads? Or as for NSN, obviously in their flexi units, they're running 3 sectors out of one radio instead of having separate radios for each sector, like a Huawei or an Ericsson or a ZTE. So there's a lot of differences in that. So knowing the OEM information is really key. Fiber type, single mode or multi-mode. At one point, just about everybody was using multi-mode, which made sense because they're such short runs. But now pretty much everybody has converted to using single mode for most of the deployments. Even NSN, who was one of the last holdouts using multi-mode. So just understanding the fiber type is key to understanding which connectors, obviously, and which testing equipment you need. Power conductor size, as we talked about, it's the surface area, the conductors, and the DC resistance that drive this, and really it comes down to the physical dimensions required. And as I said, I do have a subsequent chart I can share with everybody on that. Connector options. LC connectors, small form factor connectors that seem to be adopted for most of these deployments that I've seen worldwide. You SC or ST or other proprietary and other connectors might be utilized going forward. But as of right now, what we see is LC connectors are used into the squid and for each of the jumpers and into the remote radio heads themselves. You have connector options for power as well. Most of them are screw-on terminals or terminal blocks, but some people are using remote radio head-specific proprietary connectors for that as well. One of the questions came up prior to this asking about weatherproofing. Many of the remote radio head OEMs have mandated protection boots for the fiber optic and for the power to achieve an IP68 rating. Others are using standard weatherproofing techniques, or they actually insert the LC connector in the power terminals well inside the radio head, so that it's just a cable that it would be hanging out. So those are all concerns that you must have. So this is one of the key slides in the whole presentation, and understanding what the needs and the requirements of the deployment are. As we talked about, the side power conductors and the allowed voltage drop is really key. When you look at a 48 volts DC typical system, you're looking at 8 volts to 12 volts DC, for operation, depending on who the OEM is. Now that boils down to what the OEM spec is, but many operators that we've worked with already have allowed 3.4 or 2.8 volts DC drop. So obviously that's going to mandate that you're using a much larger DC conductor than what the OEM specifies typically. So those are key elements to understand. The breakout is very key. Typically when we've done a breakout, it's taking 3 to 4 and more samples of the breakout itself, both for the breakout of the fiber, the weatherproofing of the junction point of the from the hybrid cable or composite cable to the breakout, and what you have to do is make certain it works within their junction box and works as it pertains to the jumper, to the radio head, and within the COVP or junction box itself. So that's very key, is getting that breakout dimensions as close to the end requirement as you can. And oftentimes it takes a couple weeks to get that correct. And even if you have the best information, a lot of times there's give and take between us as the partner and manufacturing the assembly and the end customer. And oftentimes it's 50% their requirements, 50% what's feasible, and a lot of cooperation to get that correct. So that takes a lot of time, and it helps to understand the radios themselves. But when we're talking about new radios, you have to start over. And then tower heights. As you're looking at this, since most of these are pre-assembled, or the majority that we've seen, or all that we've seen, are pre-assembled, you have to understand the typical tower heights, and you're building to site heights or site lengths that are deployed. So you have to understand, for inventory purposes, the last thing you want to make is a bunch of 200-foot lengths when most of your towers are 150 feet, and then you've got to find a way, and the extra cost, both for real estate and on site, that to use excess cable storage. So it being very efficient in what those tower links are and what's needed for a site, and where your I'd say slack or excess cable is placed, so you can know what to manufacture to. Because the last thing you want is that the guy doing the site audit adds 20 feet to it, and then you say, well, we don't want to run short, so I'm going to add 20 feet to it, and then you end up with 40 feet extra. So you got to really understand that. Not only is that a lot more cost, because if you're looking at a trunk cable, it's very expensive, but it's a real nightmare in trying to work on the deployment on the site. And once you've pulled the cable, you're not going to take it down. And certainly, as of right now, it's not an option to cut and re-terminate on site, because that's a real mouthful. As looking at logistics, I give you all the options here, although pre-terminated in increments, as we just discussed, is the primary deployments we've seen. Obviously, there's the option to terminate it on one end and terminate on site on the other end. There are quick and easy connector options from a variety of sources, but we've not seen anybody take that deployment strategy as of yet. There's too many variables, and the thought of doing either fiber splicing or connectorization on sites has been somewhat of a negative for operators and OEMs that we've discussed this with. Why does a composite and hybrid cable seem like the ready conclusion for a successful deployment? Ease of handling, pulling one cable per sector, one cable per site, cost effective. If you've done your site audits right, no excess cable links on site. There is the ability to eliminate the need for conduit and junction boxes if one chooses a sectorized approach. You can future-proof it. You can add the redundancy already. Many times there's excess fiber specified ahead of time, because fiber is not your real expense. The DC power cables are much more expensive. So if you do that, you can deploy potentially other radios on the tower as the technologies are deployed at a later date. In fact, many of the deployments that are happening now, they'll have X amount that they're deploying the LTE or 4G strategy, and they'll go back to the site and connectorize the rest of those at another date. But they're already, the fiber and the DC are in the cable already, so it's merely a matter of hooking them up and putting the radios on the tower. Environmentally and mechanically protected. If you're using a composite hybrid, you have the armor which protects it, as well as an overall outer jacket, as opposed to trying to run it through conduit to achieve that. Less tower loading. Right-sized power conductors. Again, that's a key area. The last thing you want to do is over-specify the conductors, because the conductors are very expensive. Copper is very expensive. So you can right-size those based on the tower heights, and then you can save on installation costs, because it's much faster and easier routing in the enclosure and on the tower. So effectively what it does is reduce both long-term the CapEx and OpEx. Looking at the solutions, I just wanted to do another visual representation of breaking it down. So if in separate power and fiber, you would use either a 2-conductor for a sectorized or a multi-conductor for a trunk solution with a fiber roll, with an OVP or fiber management system for a full, and then the rest of the tower architecture. For the fiber light solutions, like we're currently deploying, in either sectorized on your right-hand side or a composite on your left with multiple components in it. I mean, really, you're looking at tower hardware and an OVP or fiber management for the trunks. But for the sectorized, as it's being deployed currently, it's right from the baseband unit in the system straight to the remote radio head itself. And so then you're looking at just an RF jumper or a half-inch RF jumper from the radio head to the antenna. And those are, very, very discrete and easily articulated solutions with minimal amount of product on the tower, so your leasehold costs are really efficient. Just looking at the different cables, I mean, this is T-Mo and Ericsson and just some of their specific trunk requests that we've worked on. And just looking at the multiple conductors, you have 6 and then 2 conductors right here for monitoring, if you can see them, and then your fiber subunit. Here, for an Ericsson deployment, you see there are 3 fiber subunits, still the 6 conductors, plus the monitoring pair. But this is done in the strategy where this is all one fiber breakout, so you would have to use a junction box or a COVP or squid or whatever you want to call it to break out the power and the fiber. Here, you have the option of just breaking out and utilizing the fiber right to the radio heads themselves, and handling that through your breakout method. So there are a number of ways to handle that. And then it became a product innovation that we were working on with multiple customers. On the jumper side, they were using separate power and fiber prior, even if they were using a trunked composite or hybrid solution. And composite jumpers make much more sense because each time they used a discrete small 2-pair fiber and a 2-pair power conductor, they were running those in conduit, leading to quite a bit of LC connector breakage on site. And so by using a composite jumper with an armor and the fiber and power in it, you needn't do that. And the diameter of this is such that birds and squirrels cannot bite through it readily. In fact, the outer armor, which you see in green right there, is a rodent barrier as well as a conductive element. So it keeps that potential outage from happening and minimizes the labor on site and the potential for the breaking of connectors. So it's really been a great development for multiple builds throughout the U.S. and Canada these days. Again, looking at all the elements on the site, I just wanted another visual representation of the 19 different areas to be considered for deployment, and accessories for a secure and cost-effective deployment. Everything that's specified here and that we've developed are standard coax-like accessories. So the goal here has always been to reduce installations costs, but keep it as similar as we can to the deployment of coaxial cable or RF cable, so that it's familiar for everybody in the tower-based installation world. So that's been a key from our initial strategy. And we have our AC line of accessories that we'll talk to at the end of this a little bit, that are catered towards these products and RF products as well, but to be utilized in a very cost-efficient and easy manner to deploy these in a secure fashion. So what we want to do is continue to allow for reduced tower-based real estate costs. As you look at the inserts down below here in the lower right-hand corner, as you can see, that many of these you can run 3 cables in one, so it takes up the profile of a standard 1 5/8" cable. And what that does is allow for the footprint on the tower to be much less. And again, you know, this is also extremely effective in crowded monopoles because the cable is very rugged, and the accessories you know, have been utilized in those, and whether it's a self-support, a guide tower, or a monopole in the past. So everything is very similar. So the routing and the hanging is extremely easy methods that everybody's familiar with. Breakouts and site-ready assemblies. This is really what runs this business right now, in that the key to this is secure assemblies, high-performing, that get to the site in the same fashion that they left the factory. And that's everything we do right now is to secure that aspect of it. It doesn't do you any good if you have fiber breakage as you're going to deploy. In some areas of South America, for OEMs, in my experience over the last 6 years, prior to using these composite solutions and looking at the packaging like we're utilizing right now, they were having up to 40% breakage as the fiber arrived at the site itself. And that's unacceptable when you're trying to deploy and get the network online. So one of the keys is to make certain that it arrives in the fashion that it was sent. So looking at that, I mean, there's a whole number of items that can be part of a full solution set, whether it's shelves or other modules, jumpers, trunk assemblies, panels, rugged fan-outs, etc. So this slide is just merely here to show you that there's a lot of other items that can go into this deployment. And to a certain degree, we're supplying these for many deployments, and some we're only supplying the tower-based architecture as well. But that's key as well, is that there's a full solution set that can make this a very smooth deployment for everybody involved. So here's a typical hybrid composite construction. Your outer jacket, corrugated steel or copper armor. Right now, steel armor has been utilized for many of the builds in Canada so far. There has been a movement that the tower owners in the U.S. are requiring a UL-approved product, which may require a copper armor at some point. So that's something just to keep in mind, that there are options. It's not just one option. You do have the option to utilize copper, and that can get a tray cable rating in the U.S. and mitigate any issues that American Tower or Crown Castle or somebody may have. There are ripcords in the cable itself, which are very efficient and effective at further breakout. We have a procedure that goes into how to do that, and that I can send to anybody who needs it, which it effectively means is if the fiber and the DC cables aren't broken out far enough for you to reach your patch panels, you merely pull the ripcord and break open the outer macro cable elements, which are the shield and jacket, and then you can break them out further. So we do have a procedure that gets into that. So your DC conductors are there. Those are ULCSA, THHN, THWN products, and that's throughout the whole product range that we're supporting right now, no matter who the cable manufacturer is. And there's usually there's either 1 up to 4 fiber subunits within this, any of these cables that can be broken out by themselves or broken out through frication methods. We've tried to utilize, in the sectorized approach, we've tried to utilize type buffered constructions, so that you can use those without furcating them, but you also have the option to use furcation and break them out further. Here's a sectorized composite cable site. As you can see, that's a very minimal amount of materials compared to some of the trunked sites that we looked at earlier. But the sectorized approach allows you to use a 2-conductor or 3-conductor cable if you require the ground, along with 4 or 2 fibers effectively, but usually we put 2 more in for redundancy. And you can run each of those to the radio head itself and then an RF jumper onto the antenna. Use a standard ground kit, as you can see, just like we discussed earlier, and does utilize some cable entry cushions and also which are very similar, the inserts in the hangers themselves. And that's looking at a site just in a 300-foot dual-band sectorized configuration. Here's a sectorized breakout at a remote radio head. This happens to be an Ericsson remote radio head. And you can see you have your DC and your fiber being fed into the unit itself. Very simple approach. And when you think that that's replacing 2-inch and 5/8 coaxes at a minimum, possibly 4, that's quite amazing. And then here is utilizing standard hangers. Again, this is the sectorized approach. Here's different forms of conduit that have been required. As I said, with the composite hybrid constructions, we do not need to utilize any of the conduit at all, which is a great cost savings both in real estate, on the tower installation, and the price of them themselves. I mean, while the one on the right, could be $2 a meter, the one on the left could be $2 a foot, and that's being specified for some builds. So just in general, we're looking at CapEx and overall site costs. For a composite hybrid cable installation, it's about 40 to 50% savings when compared to a typical 6-run coaxial transmission line site. So now you can, and that's another element as to why you can see that this would be a choice of both operators and OEMs worldwide. And then it's a 20 to 25% savings when compared to a typical remote radio head installation using separate power and fiber. Now we do support those. So we certainly have solutions that we're supporting using separate power and fiber. A lot of that might be rooftops or water towers or non-conventional site deployments. So certainly each of these architectures that we discussed have their own place. Here's a separate fiber and power dual band site diagram, and effectively this is what AT&T is doing in the States. I think I saw a couple names from AT&T. I was heavily involved in that when I was with CommScope. I developed the solutions with AT&T that are currently being deployed. This is using obviously still a trunked item, so you can see the squid in the upper left-hand corner. So everything goes into this bullet-shaped squid, and that would be two power constructions utilizing the 6-conductor power configurations, and 1 fiber component. They have actually just changed their fiber component from 24 fibers, which you can see here, the FTTA 24SM, to a 36 fiber, and that ultimately is scheduled to support 9 radio heads on a tower for a site as they get to the full deployment of all technologies. And again, here's just another representation of that same item, but showing some of the hangers and the inserts that we've developed for that. And then here's a composite trunked diagram. Really what this does is it eliminates the two, the use of separate power and fiber. Everything is under this one sheath. What you see here, we're showing a 2-conductor power construction that can be utilized as jumper material, which it typically had been. But now we've introduced the composite jumper, which has been more successful. But a composite trunked cable is much more efficient as it goes up to the COVP and is broken out from there. right now we're doing, at present, over 100 sites a day for a similar composite approach for a deployment in the U.S. That means that we're manufacturing the finished trunked assembly and supplying over 600 jumpers per day for these deployments, and everything's going extremely well. This seems to be the way, or the direction, that each of the operators, except for Verizon in the U.S. and AT&T in the U.S., are moving. We're getting more and more inquiries for this type of solution as the deployments have been going on over the last 3 to 4 months. And again, here's just another representation of a similar item. This happens to be an 18SM single mode fibers in it. Right now we're doing 24 and 36 fiber versions of this, and also a 36 fiber with 10 conductors of 6 gauge in it, and a much larger cable. And we're deploying those in the U.S. right now. Composite hybrid summary. I just wanted to go over it again. So sectorized, which is a strategic direction for us at Alliance as well. Home runs to each sector and remote radio head for real estate aspects and the deployment ease, and especially if you're using the radios like Huawei and Ericsson that have overvoltage protection built in that's sufficient. That's a great way to go. And then trunked, which is also strategic. That's what we've been working on mostly this past number of months. It's available in many configurations, as we looked at the slide earlier, from 12-gauge conductors up through 6-gauge conductors and on to 2-gauge conductors, depending. You can do higher count fiber, 24 or 36, as we just discussed. You can have between 2 conductors and 10 conductors as far as power, up to 6-gauge, and even more if you're using smaller conductors like 8-gauge or 10-gauge or 12-gauge. Separate trunked, key initiative. Right now, we're supplying a lot of that material into AT&T and their turf. That's been a very large program. And then there's also separate fiber and power to each remote radio head, which is not we don't believe that's strategic, but certainly for, as we talked about, non-conventional sites like a water tower or a rooftop, that might be something that somebody wants to deploy. Oftentimes, right now, that's the OEM supplied solution. So typically, we're competing against the OEM when we're promoting the composite hybrid summary. But it's really up to the operator to make the decisions what their solution should look like and what their system should look like. Here's it. We get into manufacturing, interferometer. Interferometers are widely used in fiber optics for measurement of refractive index changes, et cetera. This is what we utilize. As you can see, it's passed. We put our criteria into the system, and this is in our manufacturing process. There are a lot of other options as far as test equipment. I have information that I can share as well on JDSU fiber to the antenna solutions that they have for test equipment. There's a variety of equipment that they have available for all aspects of fiber to the antenna deployments. We use JDSU quite a bit, but this is our factory test equipment, and just we supply a test report with obviously every fiber and every assembly, and making certain that it passes the criteria that we've established for that build, and that each one changes by operator typically. This is a process flow chart, and I just put that in there just to show you. I mean, one of the key elements in this manufacturing and the assembly of these products is covering all steps necessary. And these are outside plant assemblies being deployed like coaxial cable once did. So we have to make certain that from the environmental aspects of this, heat shrink and the weatherproofing to the fiber performance to the breakout lengths, everything is extremely specific. So we're following an ISO 9000 approach to the manufacturing of all these assemblies. And that's covered in here, and we can get more specific about that at another time. We're starting to run out of time, that's why I'm speeding up. I apologize. Jumper manufacturing. Jumpers are as critical to the deployment, especially with the trunked solutions that we're deploying right now, as the trunk itself. Obviously, if you don't have them both, it's not efficient to go deploy them. So that's why when we talked about doing 100+ trunked assemblies a day that we're manufacturing right now, you have to look at it that the minimum you'll need each day to support that is 600+ fiber assemblies and fiber or power composite assemblies, and that's what we're doing on a daily basis. So 600 jumpers and 100 trunks per day is our current average. So just want to go into all of our assembly capabilities, and in this as it pertains to the assembly process. So we're doing fiber optic jumper cables, RF jumpers, power cable assemblies for some separate elements. We do some automotive wire harnesses, thermoforming, and commercial and industrial wire harnesses in the same facility that we're doing the key fiber optic assemblies now. And there's a clean room that we utilize for our assemblies as we built it some months ago. So the quality statement in our relentless drive to zero defects. Keep in mind that we're working and on all aspects of the supply chain and the testing of the products prior to the departure. So one thing that on any of the products that are deployed, if there's ever an issue with one of the assemblies that goes out into the field, there's a number and a code on each assembly, whether it's a jumper or a finished cable assembly, and we can get you your test reports immediately to define each fiber connector. So all 36 duplex connectors on each side of a 72 fiber assembly, we can get that to you ASAP and go over the performance criteria. So one of the keys is to understand that the quality that went into it prior to departure and what the test results look like if there's ever an issue in the field. So we do have procedures manuals, supplier manuals that we can share with any prospective customers. We are ISO 9000 compliant and 100% inspection and tested. And we have complete process controls and calibration of all our units. Many of you are in the Toronto area. We'd love for you to come in and see our facility and visit us. And we can supply any of the information that we've talked about here today. There are much more in-depth things to do on this topic. I would love to get more involved in the training and some of the aspects of the cleaning. I know one of the questions we had was, one of the first ones was the cleaning of connectors in the field. Typically you use 99% alcohol and use a wipe and then a clean wipe, and then we supply those with our assemblies, and then you use a dry wipe to make certain that everything's okay. After that, the interferometer that we talked about earlier, we have that at the plant, and as I mentioned, there are a number of key items that JDSU has that you can utilize in the field. Portable optical spectrum analyzers. They have their T-Bird units. Your light meters just to verify and identify the fiber and make sure you have continuity. Optical power meters to make certain it's getting there. Optical light sources for the same continuity aspects. They also have units that will differentiate the fibers for higher count cables for you. And these are all key areas. I would suggest you get on their website, the JDSU website, and look at their fiber to the antenna tools. And they have a whole list of them. We could certainly work with you on that, whether it's myself or someone else here, Darren O'Brien or Tom Morin. If you have any further questions about that, you can certainly reach me separately, and I can share that with you. We do have our own test procedures for field applications for the trunk assemblies, etc. As I said, we're running out of time, so I don't have time to go through everything there. A couple of the other questions that came up. went into waterproofing or weatherproofing. I think we touched upon that, and the test procedures, installation details, connectors and fiber tests before and after installation, or ways to maintain quality. Obviously, the packaging is key. Keeping the caps on the fiber ends is key, and the fact that we include the wipes and alcohol swabs with 99% alcohol to achieve that are the keys to that. If the caps do, however, get that do come off. But what we find is that with the packaging that we perform, we don't have those kind of issues. Typically, the packaging is very secure, and as long as it's taken off with some care, once you take the caps off, you do so after pulling the cable and plugging it in. I think that was it from the general questions. I don't know if we want to get started with some questions now, Lisa?
Hi, Carrie. Actually, we haven't any questions that anyone has submitted. I just a note to the audience if they have anything, they can submit it using the questions or chat pane. But I'm not seeing any coming in.
And you'll include my email and contact information on the letter back out to everybody?
Yes, everybody's going to get a response, a follow-up email after the webinar. Might be a couple of days, and I'm going to include a link where you can download and listen to the webinar again, or watch it if you want to, and and Carrie's contact information. Yeah. Yeah.
So I know there are probably other items that people have. I know a number of the folks you're already deploying these networks, and you might have more specific questions. Please contact me at any point. I did, as I said, over the last 6 years, I spent a lot of time in South America, Latin America, Europe, and Asia working on these type of solutions with the various OEMs, et cetera, and operators. There's a lot of specifics that go into this. We're going to develop more of that as we go forward. Right now, we're right in the midst of some very big build-outs. So this was a general overview that I'm surprised that we took the whole hour to do. But I'm glad that everybody joined to hear this, and we'd like to develop more going forward.
That's great. Thanks, Carrie. So thank you, everybody, for attending today. Like I said, I'll send a follow-up out. And if there are going to be additional webinars on the topic, I will be sure to include you in the invitation.
And
Thanks.
We would accept suggestions. So if there are items that you think should be covered going forward, please let us know, and we'll put those in as key aspects.
That's right. We will, exactly. Okay, thanks, and everybody have a nice weekend.
Thank you.